Hi there, Ms. Hedgecock here. Welcome to lesson 3.4. This lesson is about solving exponential and log equations. All right, so we're going to get started. Our first video, this video is going to be solving exponential equations. You'll have a second separate video on log equations. All right, so there's different ways to solve exponential equations. It depends on kind of the type of problem you have. So the first type of exponential equation you might see is where the base, you can rewrite the bases so that you can get a common base. So right now, if you look, I have a base of 3 and I have a base of 27. I can rewrite the base of 27 as a base of 3 instead. So you're looking for numbers that are multiples of 2, multiples of 3, sometimes 4, sometimes 5, sometimes 6. Try not to go too much higher than that. But you're looking for numbers where I can rewrite them as 2 to the 5th power, 3 to the 8th power. Oh, that's too high. But like 4 to the 2nd power, numbers like that. So 3, I'm going to leave alone. But 27 is actually, was it 3 cubed? So what I'm going to do is I'm going to replace 27. So instead of 27, I'm going to have 3 cubed. I'm replacing it. Instead of 27, 3 cubed. Because it's the same thing. It's just a different way of writing it. And then I'm going to have x plus 4 on the outside still. All right? And now what I'm going to do is I'm going to follow my laws of exponents. And when you have this cube here, I'm going to circle it, and it's being multiplied with another exponent, you're going to multiply. So I'm going to go ahead and distribute my 3. So I'm going to leave my 3 to the 2x equals 3 to the 3x plus 12, right? Because when you have like this, x squared to the 5th power is x to the 10th power. You multiply, all right? When I have the same base, 3 is my base, 3 is my base, and only when you have the same base, and it has to be exactly the same, it can't be 3 and negative 3, it's 3 and 3, what we're going to do is we're going to set the exponents equal to each other. So I'm going to do 2x equals 3x plus 12, and then I'm going to go ahead and solve. So I'm going to subtract 3x, and I get negative x equals 12, so I get x equals negative 12. And then I'm going to have to go ahead and check my answer to make sure it works, and you can use your calculator to do this. So I would go back to the original problem here, and I would plug negative 12 in for x to make sure it's true, it's the same answer. And you're going to get a decimal, and that's okay. But negative 12 will work, so this is going to be our answer. Okay, that's type 1 problem, all right? Type 2 problem is you can't change bases, so you're going to change it to a log, and you are going to use your calculator to help you figure it out. And I don't have a calculator with me. Give me 1 second. All right, I got my calculator. So what we're going to do is we're going to switch it to a log instead, and then we're going to use our calculator to help us figure out what it is. So if you look, 3 and 25, I can't make them the same base. 25 is 5 squared, so it's a base of 5, but I can't make it a base of 3. So what I'm going to do instead, what I'm going to do instead is I'm going to change it to a log. So we need to make sure we understand, was it 3.2 maybe? Switching between forms. All right, so instead of 3 to the x equals 25, I'm going to write log base 3 of 25 equals x. And I don't have any additional work I have to do besides plugging in a calculator, because x is all by itself over here. I don't have to divide, I don't have to multiply, subtract, add, nothing like that. So what I'm going to do is I'm going to take this right here, and I'll plug it in my calculator, and I'm going to round it, all right? Now, if I ask for exact form, and I say nothing about rounding, and this problem obviously says nothing about rounding, but if it says nothing about rounding, I want this as your answer right here. That is a good answer. Log base 3 of 25, because it's some kind of decimal. However, if I ask for a decimal, then I would like a decimal. So we're going to go ahead and plug it in our calculator. I'm going to do that real quick. Log base 3, 25. All right, and we get 2.93. We'll round to the hundredths place. 2.93 is x. And then we could check our answer, plug it in. It's a little harder because you want to use the exact decimal. You don't want to use the rounded one. But that is the other type of problem you'll see for exponential equations. So you can either change to make them the same base, or you change it to a log instead. All right. So I got 2 examples. I recommend pause the video, try them, and then I'm going to pause it myself on my side, do the problem, and then when I unpause, it will just magically appear for you. But pause here, try them out, and then unpause, and then see what we get. All right, and there are the answers to the 2 problems. So the one here on the left is one of the ones where you can change them so that they have the same base. So I wrote up here in the top, 1/2 is really 2 to the negative first power. So you are going to see fractions, and whenever you see a fraction like 1/3, you can rewrite it as 3 to the negative first power. That's what makes it a fraction. And then 8 is really 2 cubed. So then I can go ahead and change them to both to a base of 2, and then I can use just the exponents to solve, and I get 7/4. You can leave it as 7/4. That's a great answer. All right. The one over here on the right, you cannot have the same base, especially when you have e. Well, that's not true, but you can't have the same base because when I add 19 to the other side and divide by 3, I get e to the 5x equals 7. I can't make e and 7 have the same base, so I'm going to go ahead and change it to a log. Now, when I change it to a log, I need to remember if I have log base e, it's the same thing as ln. You have to use ln instead. So you need to recognize log base e is ln. And then I can go ahead and solve by dividing by 5 after I change to log form. And so my exact answer would be ln of 7/5, which as a decimal is about 0.39. But an exact answer is good for this one. All right, so those are the only examples for this. So the next video you're going to watch is solving log equations. All right, good luck.